In this video, we're going to talk about how we can plot satellite data with other information overlaid on it. And so to begin for this one, what I desire to do is to create a visible satellite image and then plot surface temperatures, contours of surface temperatures from the GFS onto it. So the question may be, well, where to get started? And so I'm going to start to piece this together by just initially getting a visible satellite image. So I am going to start with the satellite underscore imagery notebook. And so I'm going to duplicate this one. I'm going to send my copy to my working notebook. In my working notebook here, satellite imagery copy, I'm going to rename to visible imagery with temps, because that's ultimately what I want to do. So I'm going to go ahead and open it up here. And again, this is what we had started with last time. And so starting with something helps us out. And so I'm going to go ahead and change my kernel, since I need to do that, to Valpo Spring 2020. Once that gets going, then I'm going to be ready to go ahead and import our needed modules, use our little function here to be able to find the right time. And then I'm going to change to the 30th and grab data from, let's go 18 UTC. Oops, only need 10 there. And I want visible satellite data. And so I've got two choices. I've got either a blue channel or a red channel. And it turns out that our red channel has 0.5 kilometer spacing between each cell. So even though it's a bigger file, I want channel 2. And so we're going to go ahead and acquire that channel 2 data. And now, since I'm using visible satellite imagery, I've got this piece in here that we had previously left commented out. And so for satellite data, we often want to, for visible satellite data, this is apply a correction. And so we can actually apply a correction here to our data set by using this ds.map and then map this square root to take the square root of our final value. And we want to keep our attribute. So I'm going to go ahead and rerun this cell now with that square root done in there. And so basically this is applying just a bit of a function to our satellite observations. So then I need to change my title here, since I've got visible imagery. Visible channel 2 this will be, and plot our time. So let's go ahead and run this just to see if we can go ahead and get a map. And we've got an error here. Our CRS attribute is not available, likely the result of us taking the square root and mapping it there, so we must not have kept our certain attributes here. So I'm going to look at the DS sectorized CMI. Sure enough, that's the case. It dropped those attributes, even though we said keep the adders. So we're going to go ahead and ignore this for the time being, rerun our cell to then make sure we kept our attributes with our grid mapping piece here, so we can go ahead and plot our imagery. So for right now, we can't do our square root correction. It's okay. It's nice if we could do it, but we can't, and so that's okay. And so there we go. Woo, boy, howdy. So it looks like we're going to need the reversed image here, because where it's not cloudy, it's white, and where it's cloudy, it's dark, and that just looks funky. So let's go ahead and underscore R, get that reverse order going on here for our albedo, which is basically what we're looking at here with our sectorized underscore CMI imagery. Now this is taking a while to plot because as you saw up here, we have 6,000 grid points in our Y direction and 10,000 grid points in our X direction. There we go. Now, again, it's a bit dark. If we were able to do the square root, that would have kept that, that would make it a little more visible. And so we'll see if we can figure that out in a future video. So this is great. So we have our satellite imagery. But now say we wanted to overlay, say, temperatures from the surface. And so we're going to need a different data set for that. So we're going to want to think, whoops, turns out that our image file is a bit too big. So I'm going to go ahead and rerun this and just make it a slightly smaller file. So let's go, let's see, 15 by 12. See how that looks. Go ahead and rerun that. Hopefully that'll be small enough so we can save this intermediate file here. Otherwise, don't forget we can always go up to Edit and Clear Outputs to then allow us to save any changes that we're making. There, we were able to save. So now our title values are way too out of line here, so we're going to bring back maybe that to 80. Get that running again. So you can see how we need to iterate sometimes on some of these things to get to the map that we want. As that's going ahead and running, let's come back over here to our notebooks. And since we're looking to just do some surface temperatures, let's go ahead and open up this color filled, because I remember that in color fill gridded, we had some surface temperatures going on. And so we're going to go ahead and copy this value here. And we're going to piece some things together. So first we needed to gain access to our data. Now, do we need to use a different date? We shouldn't, since the time we chose is okay. So I'm going to go ahead and comment and actually just even delete this. We don't need that. And as we add things here, we can test out what's going on to make sure we can run. So it appears that for some reason our 18Z data is not available. Probably because that's today, since today is March 30th. So let's go ahead and go back to the 29th for this data, because then we can be sure that our GFS data is there. All right. So now back to our color-filled output here. Let's go ahead and subset. So we're just going to subset over a particular area. Oops. All right, so we've subset. So now all we need to do is add it to our image. And so let's go ahead and copy over our contour plot, since ultimately we're going to try to contour some stuff. So we can add this anywhere above our panel setting, but we don't want to plot pressure mean sea level, although we could. We want to plot temperature height above ground, so let's go ahead and copy that over. Our level is going to be our 2 meters, so we need to copy that over and replace the none with that. We're going to want to change our units to DAG-F. And we're going to change our contours here to be, say, from -20 to 100 by 5. And so let's actually make this 101, so we go fully up to that 5. Going to add some C labels there. Let's see. Well, we don't want these to be solid black, so we're going to have to change some things about this. Contour equals line. Color, let's make it tableau red. Contour dot line style equals, well, let's go with dotted this case. And then in order to add it to our plot, we need to add CNTR to add this new contour that we're adding in to our plot. So let's go ahead and run this and see if we came up with any errors. Ooh, we did not like our plot time because we've not yet defined plot time. And so in this case, we can just use date. So we've run into a problem here. We've named both things DS. So let's go ahead and change our satellite to be sat_ds, sat_ds, and then down here, our sat_ds, and then leave our GFS as just our DS. And so we need to rerun this to activate that sat_ds variable. Now we can rerun this cell. We don't have our error grabbing our satellite data. So now we're plotting not only our visible satellite data, but then also the contours of this temperature at height above ground, which is basically going to be our surface temperatures, all to the same map. And there we go. Look at that. We get our nice plot. Now, we also are showing areas at which we don't have satellite data because we are looking at just the CONUS view. And so in our panel, we can specify the area. Panel.area equals, and then in a list, we can say go from -115 to minus 65, from 25 to 50. And so that's defining a bounding box for us that's going to plot just a limited area and hopefully reduce most of that white space, but still looking at the US. And there we go. We've now got a better image that is plotting our two things over each other. Now, the Tableau red is really not coming through well. And so let's go ahead and change that. Let's change it to, say, yellow. We'll rerun our cell to see what we get. And there we go. Our yellow was a little easier to see now. And so we can see temperatures sometimes in our cloudy regions are colder than the surrounding regions. And so we can see it gets warmer just south of this cloud cover area here that was present around 1 p.m. On Sunday, March 29th. And so it's not too hard to overlay some of these things and allow us to have some of these nice plots going on. So again, you can make any overlays you want. Maybe you want to add in some wind speed to this or something like that from the model. It's all pretty easy to do. We could even add mean sea level pressure on this map if we wanted to in a different color and overlay interesting meteorological features to see where some interesting things might overlap. So I hope you've enjoyed this video, and thanks for watching.